And now it's my honor to introduce a great chemist and biochemist who has dedicated her life to the understanding of basic mechanisms of carbohydrates and of cellular metabolism, Laura Kiessling.
Thanks. So I grew up in a world where science was cool. I remember my parents waking me up so that I could watch some grainy black and white picture of some guy, Neil Armstrong, walking on the moon. We did that. Science did that. And we in Wisconsin have our own legacy of making important contributions to science. So we, by studying fundamental questions, by asking basic questions, figured out, Carl Paul Link figured out why cattle were bleeding uncontrollably. And that led to warfarin, which is used, it's on the World Health Society's most important medicines, discovered here by asking a simple question. We also have Hector DeLuca, who figured out with Harry Steenbock that you right now are making vitamin D. And that helped us figure out how to treat diseases like rickets. And basically, because of advances like that, we don't have polio, we don't have smallpox. There's some great signs here, by the way. So those basic questions, just asking, what is going on here? Why are these cows dying? What happens to vitamin D when it gets inside a human? Those have led to major advances. So basic science, asking fundamental questions, has really been important in driving the applications. The applications that industry takes all depend on that basic underlying research. And how do we know which research to trust? How do we know which ideas that people put out there allow us to make the next step? So I'm going to talk about something that you didn't expect to hear about today, peer review. So all of science depends on peer review. And so what does that mean? So when a scientist has an idea, they devise an experiment to test their idea. And then when that experiment gives them some new insight into how things work, they send it out to their competitors. They send it to their rivals to say, is this right? What do you think of it? And they do it anonymously, so the rivals don't even know, they don't even know which rivals it goes to. And of course, those people then say, ooh, I don't believe you. You need to do a lot more experiments. But that makes science great, because what we build on has been validated by other people. We know that we can take the next step. Wouldn't it be awesome if the people making policy to share their ideas, listen to the criticism, react to the criticism, and give us an evidence-based policy? I think that's what we need. We need to demand that. Not maybe the peer review part, but the evidence part. we already know that evidence for evolution is overwhelming. There's no evidence that vaccines cause autism. There's much evidence that humans are warming the planet, and that's accumulating. So when we got called by the organizers to get involved, they said, you need to give a challenge, you need to say what the next steps. And so first, we need to make sure that we as people have the facts. And one great place that talks about how to evaluate what's real and what's not real that you hear about is called Sense About Science. If you're a teacher, if you're an informed parent, just a member of this democracy, that's a great place that gives guidelines. It doesn't tell you what to believe, it gives guidelines for evaluating the science you hear about. If you're a scientist, go talk about your work, venture outside of Madison. And if you're a teacher or an educator, find somebody here to bring into your classroom. Scientists are happy to talk about what they do. Once you get them started, you will not stop them. And I'll just echo something my former speakers have said. We need to be able to look at our problems with clear eyes. It's only then that we can devise the solutions, and science is an important part of our toolkit for doing that. Thanks.